You are sitting next to a crackling fire, roughly 400,000 years ago, in what is now northern Europe. The fire is gradually dying out. The pieces of wood have burned down to a pile of black, cracked fragments that glow faintly whenever the wind blows. You reach out and pick up a piece. It is warm, but not unbearably hot. It is light, much lighter than the branch it used to be. It is hard, black, and brittle. You do not know what it is. You do not realize that what you are holding is almost pure carbon. The volatile compounds in the wood have been driven off by the heat, and what remains burns hotter, cleaner, and longer than the original wood. You do not know that this black residue will eventually allow your descendants to melt rock into liquid. It forges weapons that conquer continents. It paints pictures on cave walls that survive for 36,000 years and creates massive explosions. You just know that it is still warm. And when you blow on it, it glows brighter than any piece of wood ever could. That is charcoal, the first fuel that humans improved. And it was not invented at all. It was simply noticed. Over 1 million years ago, at the Wonderwork Cave in South Africa, humans began to control fire. Burnt bone fragments and ash deposits dating back 1 million years are concrete evidence of this. And wherever there was controlled fire, there was charcoal. Not because anyone made it on purpose, but because that is what happens when wood burns. The outer layers combust, while the inner layers, starved of oxygen, do not fully burn. They undergo pyrolysis, where heat drives off water and volatile organic compounds, leaving behind a structure that is 80 to 90% pure carbon. That is the structure of charcoal. For hundreds of thousands of years, every campfire produced charcoal as a byproduct. It was always there, resting in the ashes. The raw material for one of the greatest discoveries in human history was sitting in every fire pit on the planet, and humans finally paid attention to it. In December 1994, at the Chauvet Cave in southern France, tens of thousands of years-old drawings appeared. Many paintings depicting horses, rhinoceroses, and lions were drawn with charcoal using exquisite technique. Over the centuries, humans independently realized that charcoal leaves a mark, and marks create memory. The first recorded history was written with pieces of burnt wood, but charcoal does something that regular wood could never do. It burns significantly hotter than wood. A wood fire only reaches about 300 to 400 degrees Celsius. A charcoal fire with adequate airflow can reach up to 700 degrees Celsius. Blowing air through it with a bellows, you can push past 1,000, 1,100, or even 1,200 degrees Celsius. And at those temperatures, rock begins to melt. The green malachite copper ore melts at around 1,085 degrees Celsius. The carbon in charcoal strips oxygen atoms away from copper oxide molecules, a process called reduction. What remains is pure liquid copper, metal extracted from stone. This simple chemical reaction is the foundation of the Bronze Age, the Iron Age, the Industrial Revolution, and every piece of metal you have ever touched. It was only possible because charcoal burns hot enough and contains enough carbon to drive the reaction. The earliest evidence of copper smelting dates back to around 5000 BC, and all early smelting operations ran on charcoal. There was no alternative. For the next 6,000 years, every gram of metal on Earth was smelted using charcoal. Mix copper with tin, and you get bronze. The Bronze Age was a charcoal-powered civilization. Then came iron. Iron smelting requires even higher temperatures, roughly 1,200 to 1,500 degrees Celsius. The carbon in charcoal not only reduces iron ore but also turns soft iron into strong steel. Every steel blade forged before the 18th century was a fusion of iron and burnt wood. But charcoal requires enormous quantities of wood. To produce 1 kilogram of charcoal, you need 4 to 7 kilograms of wood. By the late 16th century, England's forests were disappearing, and that is when coal entered the historical stage. Coal did not appear as a new discovery, but as an absolute necessity. When forests ran out, humans were forced to turn to the black rock deep underground. In Old English, the word coal originally meant charcoal. The black rock pulled from the ground was called sea coal because it washed ashore, or pit coal because it came from pits. Coal outcrops exist on every continent. In Australia, a coal seam has been smoldering underground for 6,000 years. Ancient Greeks as early as 314 BC knew about these fire-catching stones. When the Romans occupied Britain, they mined coal to heat forts and public bathhouses. But when the Romans withdrew, large-scale extraction paused for 8 centuries. In China, the story is much earlier and more grand. Since the Warring States period and the Han Dynasty, coal was mined at an industrial scale for iron smelting. When Marco Polo traveled to China in the 13th century, he was astonished to witness an energy economy that Europe would not achieve until 4 centuries later. However, coal did not only have positive aspects. It contained sulfur, which made iron brittle and useless if smelted directly. Not until 1709 did Abraham Darby successfully use coke, a desulfurized coal product, to smelt iron. And thus the Industrial Revolution exploded. Coal made iron. Iron made steam engines. Steam engines pumped water out of coal mines to mine more coal. It was an eternal feedback loop shaping the modern world. But the price paid was extremely high. Severe air pollution caused the Great Smog disaster in London in 1952, claiming the lives of thousands. Mining is also the most dangerous job in human history, with methane explosions and tunnel collapses claiming the lives of countless workers, including children in the dark mines of the 19th century. Besides, charcoal did not disappear. It continued to play a vital role in water purification through adsorption, created gunpowder that changed warfare, and even produced the popular BBQ charcoal briquettes of today thanks to Henry Ford. Furthermore, coal tar, a byproduct of coal, paved the way for the modern chemical industry with synthetic dyes, antiseptics, and aspirin. To this day, humans continue to burn these two ancient forms of carbon: charcoal from recent forests and coal from ancient trees 300 million years ago. Both were discovered by accident, exploited to exhaustion, and left profound consequences for the planet. The journey of coal and charcoal is a true mirror of human history, brilliant, full of creativity, but also carrying a heavy price.